Okay. So siphele phi? Okay. Excuse me. So sense in on three-phase balance loads. Okay. Just to recap, what do we know about the balance load is that a current drawn by each what? Each phase is what? Is the same, nah? Okay. The current drawn by each phase is what? Is equal. Nah? Then the power drawn, also the power now is what? Is equal, sorry. P Y nah? P D. And the three phase has three lines. Nah? It's red, yellow, and what? And blue. Nah? Then the impedance of each phase is what? Is also the same. That is the impedance of each what? Each phase. Okay. So that's what justifies. But a load is a what? Is a balanced load. For us to call it a balanced load, it must meet all of these what? Criteria. Must meet all those criteria. Nah? Okay. Another thing we said we can connect a, a three-phase load in either what? Star or what? Star or delta. Okay, we know in a star, V line is equals to what? Root 3 times V phase. Then in a delta, the V line is equals to V what? Phase, no? Okay, that will never change. The, the line current in a star is equals to the phase current. Then the line current in a delta is equals to root 3 times what? Phase. The phase, nah? Okay. Then ke ngoku, in terms of the source, and because we are having a three-phase load, it means we'll have a three-phase what? Source, nah? A three-phase source uh, has what we call intertwined on it. Phase what? Phase sequence. Okay. There's intertwined phase sequence, nah? Okay. Uh, a phase sequence that can be given is can be y r y what? B. Nah? This is telling us the order of E voltages because we know that E voltages they are what 120 degrees out of phase in a three-phase system. Okay, so if I'm talking of this sequence RYB, it means that the voltage, the phase voltage of the red phase will be what? The reference what? Phasor, nah? Okay. Then the following one, which is yellow, nah, will what? Will lag the phase voltage, now which is red, now by what? 120 degrees, now. Then elandelayo will what? Will lead. Yeah, it's gonna be negative 120. Negative for lagging, positive for what? Leading. So if I were to draw the phasor diagram, okay, sorry. Let me use the next page. My reference is always where? Here, nah? Reference line. Nah? Every time you draw a phasor diagram, you have a reference line. Epa, nah? Okay. So, Site, the reference phasor is what? The red phase. So, meaning VRN is what? The 0 degrees. And notice, please take note of my notation. Once I say VRN, I'm talking of a phase voltage. And yeah, red phase. Okay. And always, guys, when you perform any calculation in AC in three phase, even you did it when you were doing transformers, when you're doing transformers, you don't do calculations in what? Using what? Line values. Every time you do calculation, you use what? Phase values. And I've always said that the given voltage, if they don't tell you, they just give you a voltage. That is the what? Line voltage. A given voltage is always the line voltage when you have to convert it to phase voltage. So I'm saying that vector is the reference. Okay, so that is why I'm putting a 0 here. Okay, that means uh, the reference phasor, which is VR according to the sequence, will lie on the reference what? Line. VR what? RA. Okay, if a sequence it can be given to you, or if it is not given, you always assume what? R, Y, what? B. The following phasor, is the yellow phase, na? Okay. So V, Y, what? And say the following one will lag by what? 120. Hence, this is what is minus 120. Okay. So I go to my reference phasor, na? And I need to straight song one 90, na? So it's beyond 90. Let's say 120 is somewhere around there. Okay. You take a negative angle, you rotate what? Clockwise. Please, Nagase square N6. I mustn't be teaching this here in the vector diagram. Okay. So this is what? V, Y, what? N. Okay, elandelayo kwi-phase sequence yam yintoni? Is the blue phase. The blue phase is leading what? The reference, which is the red phase by what? 120. So we're gonna say positive, it is leading. Positive, it is a leading what? Angle. B, B, N, 120. Okay. So I'm gonna rotate what? Anti what? Clockwise towards that is a positive angle. Okay, so we can see, okay, if we can see this is my vector diagram. If this is, you must be able to analyze it. Yeah, I trust that you did analytical geometry and stuff. Okay, but we know that a complete rotation is what? 360. So this is 220, this is 220. To make another 300, to make 360, that means this angle is also what? 120. Okay. Suppose I was interpreting the relationship between the blue and the what? Yellow. Nah? Let's say I take the yellow phase as what? The reference. For example, I'm interpreting the phase relationship between the two, and I'm taking the yellow phase as the reference. So here is the yellow phase, and here it is. Nah? For me to get to the blue phase, which direction of rotation do I rotate? Clockwise. Nah? That means, how do I state the relationship? That means the blue phase lags what? The yellow phase. Yeah, so yeah, that's how you interpret it. In vector diagrams. You look at which one is my reference. Mm. Another thing, guys, and from it's regards to Indoni, a power. Okay. Okay, lastly, before I move on to that, another criteria that I've forgotten, sorry, another criteria that I've forgotten is that a current through the neutral, ibang bani? Ibang wo? Zero. To say the load is what? Balance in a what? In a star what? But again, then I apply in a what? In a star, in a star load, ne? But Lena, good general, this one. This one is more general. All in all what? Loads, whether it's a star or what? Or a delta. But in a star, there's another one, which is the current through the neutral is what? Zero. So when you are calculating the current through the sorry, you add what? The phase what? The phase current. So IRN plus IBN plus IYN. You add all of them. Ne? Remember, you are adding them in what? In complex form. Okay. Because you must account for the fact that these currents are not in what? In phase. Okay. So in power, in a three phase, you can calculate it as follows. Let's say in the red phase, you can use this formula VRN times what? IR bunny and times the power factor of that phase. Okay, that is the power factor of that phase. Then PYN VYN I what? N times the power factor of that phase. Okay. Then that is for the yellow phase. For the blue phase, okay, APN times IPN times the power factor of the what? Guys, each phase in a power factor ion, eh? Okay, but okay, because the load is balanced, in this case, when the load is balanced, they will have the same power factors. That is another criteria. So they will have what? The same power factors because the load is what? Balanced. But when you encounter a balanced load, you find that each phase has a different power factor from the other. You see when you're doing in calculations. Uh, okay, that is power for each phase, ne? But ke ngoku in a balanced load, sithe the power drawn by each phase is what? Equal, ne? So if by the total power, I can just only calculate the power of either of these phases, ne? Then multiply it by what? By 3. Huh? So 3 P R what? And make, for example. That is what? That is how I calculate money total power. Okay. One of the formulas that I rather prefer when calculating a power is this one. Okay. This one I may for the power factor and the angles. What I need is the phase current and the resistance of that impedance. Okay. Remember, impedance is made up of two values, which is the real part. The real part is resistance. The imaginary part le reactance. So when impedance must let's say I'm making an example. Resistance plus, must you say plus when it is an inductive what? Reactance, So when I just gonna take this value, also substitute up here, part was the value and I say is what? Your resistance. For low phase, okay, for the phase that you are calculating a power on. Okay, okay, okay. Uh okay, there's another one where you use what? The square root. That is for when you're using the line values. Okay, that is for when you're using the line values. Um, did we do example 2.8 together? No, ne? Let us do example 2.8. Examples zezam activities zezenu, ne? Okay, example that are made for me. Then activities are made for you. Yeah. Okay, we're gonna go through that example. It says there a three-phase alternator, ne? Okay, we are getting the source. Our source here is a what? Is a three-phase what? Alternator now. Supplies a three-phase balanced what? Star connected load at what? 400 and 40 volts. The impedance of each phase is what? 30 minus what? it tells us this load is balanced because Basnika only one impedance. They are saying for each phase, this is the impedance. Yeah, but they don't need to give you other impedances because this is the only impedance. Ekoyona. Prove that the current flowing through the neutral is what? Take the take VRN as a reference and use a phase sequence R Y what B. So let us write down our givens. Here we are told that we have a three-phase supply, a three-phase alternator that supplies in a balance. So that is important information. What is balanced in a then now they say star connected. So it's a what? Star connected. Then star connected load at what? 400 what? Volts. 440 volts. So bano uvi kuvi bani kuvi line guys ne. I said the given voltage is always what? Line voltage. Remember? Then the impedance of each phase. Okay. So the impedance of R and the impedance of Z, Y, and the impedance of Z, B, N is equals to. Guys, what circuit elements do we have in each impedance? What is this? This one? Capacitor. Good. Nah? So each phase in a resistance and what? Capacitor. Nah? Capacitor. Okay. Then they say that prove that the current flowing through the neutral is what? It's zero. Nah? We must prove that nyan it is what? Balanced. IN is equals to what? Zero. For a balanced what? Star connected what? Load. Yeah? Okay. Then they say use a phase sequence which is R Y what? B. That is the phase sequence. That means I take the red phase as what? The reference. I take the yellow phase is lacking what? The red phase. The blue phase is what? Leading the red phase. Okay. So if I were to draw the schematic, it would be something like this, guys. Guys, I'm using it's second symbol for Indoni impedance. I don't have time to draw a capacitor and resistance. So I'll just say this is the first impedance R bani, Rn. This is the second impedance Y what? And this is the third impedance B what? And so L color, this is what? My load. This is my three-phase load tetrahedron. Then it is supplied obviously by a star connected supply. Yeah? Okay. This is my what? Source. And it's more like in a DC circuit or your first chapter's basic circuit, this is like your battery. This is your what? Your source. Okay. What we need to get, we must prove that INT is equals to you add all what? The phase currents, nah? IN, which is the neutral current, you add what? The phase current, and in a balanced load, they should give you what? Zero, nah? How do we calculate the current? We always use what? Ohm's law. I told EN for Zamba, the entire course of electrical engineering is based on these things: current, voltage, and resistance. That is the entire course, Yomba. And the Ohm's law. Okay? Ohm's law applies everywhere. But hence, I'm saying when you are going for an interview, if you don't know Ohm's law and you call yourself an electrician or Otofunemban, there's a big problem because that's the first question you would ask an electrician. Yeah. How do you check someone knows something? You look at the basics, but does he know the basic? Yeah. How do I tell about okay, this is a soccer player? Can he trap the ball? Can he pass the ball? Basically, knowing Ohm's law is like trapping and passing the ball in this course. Yeah. So we're gonna use Ohm's law, which is IRN, né? But because this is an AC circuit, in an AC circuit we don't say total resistance, we say impedance. Because in a DC circuit, the reactance is what? Zero, né? Because it DC does not have a what? A frequency. Unless it is a pulsating DC. A pulsating DC maybe will have frequency, but a pure DC signal has no frequency. So a reactance is not what? A problem. Yabo? Okay, Londo, we don't include singainazo into ekuthiwa zii-inductive reactance, capacitive reactance when we are doing what? DC circuit. Okay. Because remember, impedance, both of them, they are a function of what? Frequency. You will see that when you do N6 harmonics, okay, they are affected by what? The frequency. Okay. Guys, if you had to assume frequency, what value would you assume? 50 or 50 hertz, sorry. That is also an important question for the interview. What is the standard frequency in this country? That is 50 hertz everywhere. That is why if anything esebenza umbane apha eSouth Africa, it must operate on 50 hertz. If ungayothenga eChina, mhlawumbe eChina ke bano-10 hertz, ayizusipana. Thina sipana ngo-50 hertz. That is why izinto they are standardized in every country. Yabo? For example, i-voltage yase-America won't be the same neyala. If you take a laptop or an appliance from an American London, you plug it here in this country, it will burn out because Tina we use 220, one they use 100 and 110, 115 as a non standard voltage because a country ihamba nge-rules and regulations. Yabo, America is saying for us 110 volts is safer to use in a, in a place that is occupied by people. Up in South Africa, we are saying, Tina, right to 120 is what? Safer to use. And maybe they'll say, justify and say it's also efficient using 220. Yeah, bro? So VRN, ZRN. Okay. Then the yellow face would be VYN, ZY what? And then the blue face would be VN, Z what? PN. Okay. So I need to know. So guys, I need to know what is my current through the yellow, the red, the yellow, and the blue. Yeah. So the first thing I have to do, I need to write a voltage exam in what? In polar form. Okay. So, but before I do that, I need to find what is the phase value. Because all zonke voltages they will always your voltages they have the same what value. The supply will give you the same value of what voltage, irrespective whether it's yellow or blue. The only difference is what the phase what phase angle. So 440 over what root what 3, because it is a what a three phase load. In a if it was a delta, that given voltage would be the same as non-line voltage. 154, okay, 254,034 volts. Okay. Now I write each voltage nine, so OVRN is gonna be 254,034, and with the angle being what? Zero, Then the next one is the yellow phase, which is gonna be 254,034 with the angle being what? Negative money 120, Okay. OVBN is gonna be 254,034 positive what? 120. Okay. Impedance is not a problem. Impedance, because impedance it in E1, but basifake in what? Polar. Now let's put it in polar. Oh, 36,05 what? 6. What is the angle? Oh, negative, so 83. Okay, sorry. 33, comma 69. Okay, degrees. So let us find the current. Uh, I'm gonna have a 254, comma 034 angle what? 0 divided by what? Bring my value 36, 36, comma 05056. The angle negative 33, comma 9. Okay. What is the current for the red phase? 7,03. Sorry, 39. The angle is positive 33, comma what? 9. Nah? Okay. Can you please put that in rectangular because we're gonna add one, go, go five, 5,84 what? Uh, plus or minus say plus body 3,9 body 2. Guys, this is the common mistake when you born. You guys not punching in calculator, guys. Day three. But if you can see that could no zero, you round off to what? Two. Sorry, 3.90 over 3 put a up. Kubani, 7. Okay, sorry. 7.046. Guys, I need to make uh, 0.69. I need you guys to make sense of this. That angle is what? Positive. Makes sense because we have a capacitor partner. The current leads what? The voltage. Okay. Then 5,863. Oh, oh, 5, 6 is. Sorry. Sorry, guys. Writing You write it in. So sitting by plus J 3,9 what? 8. Okay, let us go to the what? Yellow phase. Sorry. Sorry. It's it's about 254, sorry. Yeah, final voltage is angle. Kalau Londo, you must do your phase sequence correct. Yeah, if you do your phase sequence correct, you'll get your incorrect. You'll get a wrong what? Answer. So here it lags. Sihamba ntoni? Phase sequence. Even the impedance iyafana, which is 30 what? 36, 0, 056, comma 69. 7,94 what? 6. 7, okay. 18. 7,04 what? 6. Angle -80. comma 3, 1. Yeah. Okay. Let us put that in what? In rectangular. 0, comma 4, 5, what? 3. Uh, minus J 7, comma 0, what? 3, 1 amps. So let us go for the blue phase. 254, comma 034 angle 120 36, comma 056 33, comma 69. So I'm using positive angle there. By any answer? Okay, still gonna be the same current 7,046. The only difference will be the what? Angle. And it's gonna be the same current because we said, guys, they draw the same what? Current. Yeah, just that is current, that's just what? Out of what? Out of phase. So we must consider the angle. What is the angle? 153, comma 6 what? 9. Then how do you write it in negative 6, comma 316? Plus J 3, comma 123. Okay, now let us add all these angles to get what? Let us add all these, oh, sorry, these currents to get what? The neutral current. Okay, and current phase ngubani is 5, comma 863, 5, comma 863, and what is J plus J plus J 3, comma what? J 3, comma 90 what? 8. Yeah. Then yellow phase is what? Plus 0, comma 4, 5, 3 minus J 7, comma 0, 3. Is it 3, 1? 1 donor? Okay. 1 plus, okay, that is negative. So I can just write that negative because positive doesn't affect what? The sign. Nah? So plus negative 6, comma 3, 1, 6 plus J 3, comma 1, 2, 3. So, kubani ke? Ku? Minus 0 na? 0. So we have proved that in a balanced load, the what? We have proved that the current through the neutral is what? 0 na? The zonke za current. Lona benizibeka in pole. You're in rectangle and it's zonke current phase nganye nazi-eta to because current ebalwa if you want to calculate the neutral current, you add all your what? Currents to get. Then you get the current through the what? Neutral. So I should get a 0 because this one is what? Say balance load. But in honest truth, practically speaking, there's no such thing as a what? A balanced load. I don't care where you can go. The only thing that has a balanced load, a three-phase, is a motor. Yeah. There's a test that you do try. There's a test that they do. And I'm not sure whether they call it a continuity test, but if you measure the resistance of a winding, those resistances must be within a specific value. Yabo. But they are not perfectly balanced. So ayikho into ekuthiwa yintoni perfectly balanced load because icinge nawe if abantu abasebenza, think of it like this, abantu abasebenzisa umbane kuwe esitratweni ane usebenzisa umbane ngothini ngokulinganayo ngeke yeah, it's impossible yeah. So there's no such thing as a perfectly balanced load. So ubunofumana maybe 0 point or that is not a problem as long as you are getting the zero. Yes. Uhamba isiku eh, ayikho enye engene. Kaloku i-three phase, you've learnt it from N3, N2. Three phase, the 3 seconds or the three single phase, three single phases eziyintathu, they are always out of phase by 120 degrees. I'm sure it's not the first time uyiva le engene. Yeah. 120, I'm sure you are familiar with 120 xa kuthethwa ngentoni? Nge-three phase. Kwi-three phase, if your voltages they are always 120 degrees what apart. Yabo. If that was not the case, i-line voltage ibingazubanzi. This formula would be what? Incorrect. Yabo. It's just that it deriviwe phaa encwadini, but because of time, we don't have time for that. Yeah, akho vet apha no who's and they have the whole vet they have the whole year, the whole time in the world to learn those things. Yeah, here we have what? A trimester, 3 months you so bad, yeah. So ikhona yona phaa encwadini bayayiderive. Yeah. Okay. Sorry? Okay, let us go back to the vector diagram. If vector diagram is it's important or question ayitsho uyenze yabo. I don't know mhlawumbi zingabala imaths yabo zingabala. I would say to be safe rather draw it because you need it anyway yabo, because xa ubala i-angle you need intoni i-vector diagram. I'm gonna show you guys something now kubani angle ye-current yethu yokuqala yabo, yeah, red phase let's see. Current year red phase is what? 36, 33,69. Yeah? Okay, if I were to draw that on my vector diagram, okay, that is a positive what? Angle. You must remember a reference here to which one? The red phase. Always, I'm gonna draw according to the what? Reference. So, let's say 33 comma is somewhere here. Okay. And remember, guys, you must make a vector a current to be smaller than intoni. Oh, sorry. To be smaller than intoni. Yeah, voltage, because a current is always smaller than intoni. A voltage, Okay. Because why current is dependent on what? Voltage. If there's no voltage, we know that there is no what? Current. Okay. Uh, That is that 36. That is that positive 36 comma what? Yes. Ithini elandelayo ke ngoku ke? Sorry. Okay. It's negative what? 86 comma 3 what? So that is below what? 90 degrees, na? So since it's a negative angle, okay, since it's a negative angle, so color always from my reference. So I'm gonna go what? Clockwise, na? Let's say now go negative what? 80 no, na? That is I y what? N. Mhm. Then ithini elandelayo for i-blue face angle? Go. Is it positive or negative? It's positive. Okay, good. Sorry, blue face. So nisuka from where? Reference. Let's say one button. So usuka apha ukuza kulena bani? One button, 120 na? So beyond 150. Let's say UP is there. We call that I what? B what? BN. Guys, this is where I wanted to come to. Never use these angles when you are calculating a power factor. Okay? Please. When you're calculating a power, Rn or a power factor, and you say, okay, I Rn ne, times what? I what? Rn cos. Le angle esithetha ngayo pha ayiyo that is what? Ayiyo the one that is the reference from the reference phase. Is the angle between what? The current is the angle between VRN and what? IRN. Of which is kuleyo cala you would get away with it. Yeah, okay. So because the angle between this one and this one is what? 30 and ban. 33 comma 69. Okay, which is fine. Kaubala leyo cala power factor or a power. But when it comes to this one, P Y N equals to V Y what? N I Y what? N cos R bunny. Your cos Y bunny. N. You cannot use that angle, male angle. Your power, your power level is wrong. Or your power factor is wrong. You must use the angle between what? The voltage and the what? Current. So if ukusuka apha bani, ukusuka apha ukuza apha siyobani? 86 comma, sorry, bani? 36, 86 comma 31. Usuka apha ngo-86 comma 31. Then ukuya phana ngubani? 120. So the angle bani is basically 120 minus bani ko 130, comma 69. Okay, with regards to angle, guys, you will take in on it a voltage as in on a reference. To for me to get there, how do I rotate? Anti-clockwise, yes. Okay, which means this is by the angle is about positive. Yabo. So ka ndibala ke ngoku le power ndizosebenzisa which angle? Andizusebenzisa la 80 into upha because that 80 into is referenced phi apha yena. It's not reference to i-current ne-voltage yayo. Yabo? Okay. So wena ujonga umntu nomntu wakhe. Yabo? Jonga angle between umntu nomntu wakhe. Yabo? Let's say I'm coming to the blue phase. I'm not gonna use this angle because this angle is reference from the red phase. Kan bale power. I'm gonna say okay, ukusuka apha ukuza apha ngubani? 150 what? So the angle between the two, because ukusuka apha ukuza apha ngubani? 120. So la angle ngubani? 156 minus bani? 120. Ane? Then you ask yourself ke ngoku, kuze ndifike apha, mele ndirotate njani? Clockwise, I'm referencing kwi-voltage yayo. So that is a what? Negative what? Angle. Okay, and you find that zonke ezi angles zizofana izoba ngubani? Remember I said kwi-balance load, the power factor will be what? It will be equal. Yeah. The power factor in will be what? Equal with balance load. But you won't escape with unbalanced load. You have to do this analysis. Yeah. Okay.